In this video, we are going to learn how to rationalize the denominator. So let's get started. Let's take a look at the square root of 50. We've already learned that we know how to break down the square root of 50. We're going to go ahead and simplify it. So I'm going to make my factor tree, and I can go 2 times 25. And 25 I can break into 5 and 5. And then I go ahead and look for my pairs. And so I have a group of 5s here, and I have a 2 that's all by itself. So I take those 5s and I multiply them together. So 5 times 5 is 25. That's still in the square root. And then I have the square root of 2. So I know that how I have it written right now is good because 25 times 2 is 50 and they're both in square roots. Well, we know that 25 is a perfect square, and the square root of 25 is 5, and I'm left with the square root of 2. Well, we're going to go ahead and kind of take this concept so we can learn how to rationalize the denominator. And we have this rule. And this rule in mathematics says that there is no radical, which is a square root, in the denominator. So anytime we see a square root in the bottom of a fraction, we have to try to get rid of it. So let's take a look at this example. We have the square root of 30 divided by the square root of 2. Well, since they are both in square roots, I can go ahead and try to divide them. Well, 30 divided by 2 is 15, so my answer is the square root of 15. Now notice I don't have anything in the denominator, so this is an okay answer. Now I could try to break down the square root of 15, but I know that the only way to get 15 is 3 times 5 and there's no pairs there. So we're going to leave it as the square root of 15. All right, let's look at this. The square root of 9 divided by 4. Well, we know that 4 does not go into 9 evenly. So I can think about it as rewriting it as the square root of 9 divided by the square root of 4. I can just take the square root of the top and the bottom. Well, the square root of 9, that's a perfect square, which is 3. And the square root of 4, well, that's a perfect square, is 2. So my answer is 3 over 2. And again, I'm okay with that answer because do I have a radical in the denominator? The answer is no, so I rationalized it. Okay, let's take a look at this one. The square root of 15 divided by 2. I'm going to try to divide that out. 2 does not go into 15 evenly. So I'm going to rewrite this just like we did above. The square root of 15 divided by the square root of 2. Well, unfortunately, 15 is not a perfect square, and 2 is not a perfect square. So what we're going to do is we're going to rationalize. And we're going to make a little note here. When you rationalize, you multiply the numerator and the denominator by the radical in the denominator. So if we want to rationalize, meaning we want to get rid of the square root in the bottom, to do that we multiply the numerator and the denominator by the radical in the denominator. So let's look here. In the denominator I have the square root of 2. So I'm going to multiply by the square root of 2 over the square root of 2. Now the reason why we have to do it to the top and the bottom is because what's the square root of 2 divided by the square root of 2? Well, that's just 1. And we can multiply anything in the world by 1 and we'll never change it. So now what we have when we multiply straight across, since they're both in square roots on the top, the square root of 15 times the square root of 2, 15 times 2 is 30. So it's the square root of 30. And on the bottom, 2 times 2 is 4, so I have the square root of 4. Well, that's perfect because look what happens in the denominator. What is the square root of 4? Well, it's just 2. So I got rid of the radical in the denominator, and now it's just a 2, and on the top, I have the square root of 30. Now I can try to break down 30. I can go 2 and 15, and then I can go 3 and 5, but I have no pairs, so it doesn't simplify. So my answer is the square root of 30 over 2. Okay, let's go ahead and try some more examples. Let's look here. We have 6 divided by the square root of 3. So for this problem, I'm going to go ahead and rationalize, meaning I'm going to multiply the numerator and the denominator by the radical in the denominator, which is the square root of 3. So I'm going to multiply both by the square root of 3 over the square root of 3. On the top, the 6 is not in a square root, so it can't be multiplied by that root 3. So it just ends up being 6 root 3. On the bottom, square root of 3 times square root of 3 is the square root of 9. And I can go ahead and simplify that, because on the top I have 6 square roots of 3. On the bottom, the square root of 9 is 3. I can do one more thing to simplify this. If I look at the 6 and the 3 here, they are both not in square roots, so I can try to simplify that. And I know 3 goes into 6 2 times, so my answer is 2 square roots of 3. Okay, I want you to try this next one. Pause the video, and when you're done, come back and let's see how you did. All right, welcome back. Let's look at 5 divided by the square root of 2. I'm going to go ahead and rationalize. So I'm going to multiply by the square root of 2 over the square root of 2. And on the top, I get 5 square roots of 2. On the bottom, the square root of 2 times the square root of 2 is the square root of 4. So I'm going to continue to simplify. I have 5 square roots of 2 on the top, and the square root of 4 is 2. I'm going to try to simplify if I can. I have the 5 on the top and the 2 on the bottom that are not in radicals, but 2 does not go into 5 evenly, so I'm going to leave my answer as 5 square roots of 2 over 2. All right, I want you to try one more. So go ahead, pause the video, and when you're done, come back and we'll see how you did. Okay, welcome back. So let's try to simplify this one. We're going to rationalize because I don't want a square root of 5 in the denominator. So I'm going to multiply by the square root of 5 over the square root of 5. In the numerator, so the top of my fraction, I have that 5 right here that's not in a square root, so that's going to stay outside. But then I have the square root of 2 and the square root of 5, which gives me the square root of 10. And on the bottom, square root of 5 times square root of 5 is square root of 25. I'm going to simplify 5 square roots of 10 over, well, square root of 25 is 5. These two numbers are both not in square roots, and I know 5 divided by 5 cancels, right? It just ends up being 1. So my answer is the square root of 10. So there you go. That is how we rationalize denominators. You are going to have some more practice with this later in this session, so good luck.